All right. Can everyone hear me? If so, please just throw something in the chat. I was having issues earlier with my microphone not working. Perfect. Thank you. All right. Give me 1 second. Let me pull up my PowerPoint. So, get back to the beginning. Let's see. Share. Can you all see my screen? Why is it not showing the chat? Perfect. All right. Let's go ahead and get started. All right. So, my name is Sam Taggart, for those of you who don't know me. I own a small company in Denver, Colorado, Golden actually, called System Automation Solutions. And there's a link to our website. Go check it out. We've got lots of cool content on there. Try to post blog posts regularly. And I also have some free tools and stuff that I've been working on, and links to a lot of my presentations and videos. So it's worth checking out. So this presentation is one that I put together for the past NI week. So you'll see a lot of the slides all say NI at the bottom. I didn't bother to go back and change that. And it's on continuous integration. And it's meant to be an introduction. It's meant to show you that it's not as hard as you think to get started. It's something you can start playing around with and try to figure out how to automate all the boring stuff that you do every day. And so the premise basically is that, how do I get rid of this thing that's blocking my screen? 1 second. All right, I guess I can't get rid of that. Okay, oops. So, you know, we automate stuff for our clients, right? If we use LabVIEW, that's what we use it for. And yet we still do a bunch of boring and repetitive stuff, right? So we're constantly running unit tests and doing automated builds, right? But we have to press a button, right? We have to remember to run VI analyzer and all that type of stuff. And basically, continuous integration says, well, there's one thing that we should do every day, right? Which is using source code control and pushing our changes to some sort of central repository. And what if, when you do that, you could automatically trigger these tests, the VI analyzer tests, the unit tests, things like that. And what if you could automatically build your code and possibly even deploy it, right? Whatever that means, whether it means publishing a VI package, or an NI package, or whether it means putting something on a server and sending an email to your client, whatever that happens to mean for you. And so that's the promise of continuous integration, is to eliminate a lot of those boring things. So our agenda, we're going to talk about GitLab CI basics. I'll walk you through what CI is, how it works, how the GitLab paradigm works, which is different from Jenkins. I don't know if anybody's used Jenkins, but Ryan is not getting my audio. Ryan, you could try the call-in number. That might help. Actually, I'm telling him that, and he can't read it. Let me type that in. Okay, so talk you through the basics of GitLab CI and how it works, and then I'll walk you guys through a simple demo. If anybody wants to jump ahead, you can go to that link and download the zip file that has all the files for the demo that I'm going to do. And then we'll do a little bit of questions at the end. All right, so for CI basics. So originally, I thought that the main benefit of continuous integration was simply the fact that you're automating all this boring stuff. And that is true, but as we're going to see, that there's a other benefit that I think is probably even more powerful. Right? But here's my motivating examples. All right. So how many people, and I'm sure I'll see a lot of hands go up, think that if you have an awesome app that you built that runs in the development environment and you want to turn it executable, all you have to do is simply create a build spec, quick build, and it'll create an executable, and then you can just run it and it'll work fine. Right? So I don't know who else has been through all the NI classes, but if you have, right, you probably know that that's not true. That doesn't always work. There's a whole section in LabVIEW Core 2, I think, where we introduce building executables, right? And it talks about all the things you have to think about, and there's way more than just that. And so, you know, there's a phrase, build early, build often, right? You want to build your code consistently all the time so that when you introduce problems, you can find those problems early. Right, but it's a manual process. You have to remember to go build your app regularly. And same thing with unit tests, right? You can write a bunch of unit tests, but they're only really good if you actually use them on a regular basis, right? And if you're into the unit testing thing, you should check out my video from GDevCon #2, which was last week. I gave a presentation on test-driven development. Excuse me. And that talks a lot about unit tests and about flipping the paradigm so that you're not writing tests after you write your code, but write the test first and let that drive how you write your code. And there's a lot of benefits from that. So that's worth exploring. But I used to think, you know, again, the main benefit is just not having to remember to do these things. But there's actually another benefit that's even more important. And that is spending less time debugging. So how does that work? Well, you know, the whole point of doing the build early, build often is to catch problems as quickly as possible. The whole point of running unit tests is to catch problems before they get shipped out to your customers. And so the more often you run those, the less code you have to look through to figure out where your problem is. So if you run those on every check-in, then, you know, and it passed the last check-in, you change something, now it doesn't pass, you know exactly what broke, you know exactly which spot of the code to look at because you know what you changed. Contrast that with if you run these once a week or something, right, and you've got a whole week's worth of changes to sort through, and hopefully you check them all in separately into source code control, right? So, but now you got to go back through each check-in and run your tests again, run your build, see which one failed, then look at, well, okay, well, what changed in that section, and then find the cause of the problem. And so you spend a lot of your time just searching for the problem and not fixing it. And so CI lets us, by closing that loop and closing the time between when we introduce a problem and when we notice it, that's going to help us spend way less time debugging, right? So you still got to fix the bugs, but you don't have to go hunt them down. And that's a significant portion of the time fixing bugs is just hunting them down. So that to me is the big main benefit. All right. So before we dive too much further, we got to cover some very basic terminology. And this is the terminology that GitLab uses. There are other paradigms. I think they're all fairly similar, but don't quote me on that. So basically we have the biggest building block are stages, and each stage can have a bunch of jobs inside of it, and the stages execute serially. So in this particular pipeline, the test stage executes first. If everything in that passes, then we execute the build stage. If everything in that passes, then we execute the deploy stage. And then inside each stage, we can have multiple jobs, and jobs can actually run in parallel. So the VI analyzer and the unit testing, if we had two different machines set up, we could run those in parallel because they don't impact each other. Right, so stages run in series, jobs run in parallel. And then how do we pass data between the jobs? And why would we want to do that? Well, for example, if you're building an executable and an installer, and you want to deploy that, you know, your deploy stage is a separate stage. How does it get access to the executable and the installer that you built? You use something called artifacts, which are used to pass data between the jobs, and it'll actually also store those on your CI server so that you can access them later. Do you have any questions so far? It seems like you would want your tests to run after the build, or at least some of them. Is there a mechanism for that? So, Chris, to answer Chris's question, the stages, you can arbitrarily move them around. You can call them whatever you want, and you can run them in any order. So, for the testing, it depends, right? So if you've got unit tests, they're testing source code. And if you're building an executable, you can't really test that afterwards, not with unit tests. You'd have to do some other form of testing. So maybe some kind of Windows thing that like moves around and clicks buttons and then records what happens. I know there's some stuff to do that. I haven't really used it. One thing I've been thinking about is, especially with the web apps, is building web apps and then testing them using some browser-based testing solution. So like something like, I'll type it in here, Selenium. So if you were to build, you know, the GUI for your program was a web app, you could use something like Selenium. So building source distributions, yes. So for building source distributions, yes, you could run tests afterwards. And as an example, and we'll talk about that in another couple slides, I've been thinking that for building LLBs, or not LLBs, PPLs, right? So if you build a PPL, right, and you've written unit tests for the library, there is a scripting method that you can run that will take those same tests and replace the LVlib with the PPL, and then you can run those same tests again. So then you could test your source code, build your PPL, replace everything in your test, and then run the test again to make sure that your PPL is doing what you think it's supposed to be doing. So I think that's pretty cool. Any more questions? Yes, the VI analyzer does present problems. There are ways to ignore failures. So in the GitLab API, when we do the YAML file, there are ways to say, yes, it's okay if this one fails. It'll still send you an email, but it'll still continue with the build process. And one of the things I've done with that, and I need to figure out a better way to do the VI analyzer stuff, but right now I just run it on everything. So there's one VI analyzer file, statically calls out all the VIs in my project, and I run that. And the way I have the steps set up, the wrapper that I put around that to run that test will send you an email if anything fails. But if less than a certain number fail, the build keeps going and everything's fine. If more than a certain number fail, then it will stop the whole process. And so like I will take stuff, for example, if I inherit a project, I will run VI analyzer, note how many failures there are, set an upper limit, and then as I'm working on it, right, if the number of failures goes above that limit, then I know I've added more failures and not made the code better. And then over time, I can slowly like lower that limit. So that's just an idea. The one nice thing, PPL. PPL is a packed project library. That is way beyond the scope of this course, but if you look up Matthias Baudot, he has a presentation on PPLs and he explains it really well. Basically, it's like an LVlib. So you've got a library file, in this case, got a P at the end, LVlib for pack. And you can drop VIs out of that on your block diagram and everything, but all the code is compiled. and not source code. That's the short definition. There's a lot more to it than that, but if you watch that presentation, it tells you everything you need to know about it. It's totally worth your time. All right, so here's a real-world example that I shared in my presentation at GDevCon. And oops, I was working on this project, and I was trying to do some test-driven development, write the test first, and then write the code. And I thought, oh, well, I'll integrate that with continuous integration. And this is my initial thought, right? I figured I'd have a testing stage, right, that would run VI Analyzer and JKI, VI Tester, Unit Test Suite. That's what I use for unit tests. And my thought process was to run that on every branch. So I use Git, right, GitLab. And I had a branching thing at the time where I basically had my master branch, and then anytime I want to do any work, I create a feature branch, do my work, and then merge it back into master. It's not quite Git flow, which I've kind of graduated to. And we can talk about that at some point too. But basically that was going to run every time I check in and I push it up to the server, those two things would automatically run. And then I was going to build the VIP file. So this code I was going to distribute via VIPM. And so my plan was that every time I commit it to master, right, which means I've finished my feature, it's ready to be released, commit to master, and then it would build the VIP file. And then I was going to do a test install. So I was going to install the VIP. And then I was going to take my tests that I had before, my unit tests, and replace them so they're not calling into the source code anymore, but they're calling into the actual installed code, right, which is in VI-lib, and run again and verify that it works. And then my thought process was that the next thing I would do would be to deploy it, right? So on my master branch, I would have some sort of tag or something that would then cause it to do upload everything to Nextcloud, the latest package, and then just email a link saying, hey, here's the latest code. So this brings up an important point. Continuous integration is an awesome tool. I kind of feel like it's icing on the cake, right? So if your basic processes around writing software are not very well defined, continuous integration might not help you, right? It's not going to help you with bad design. It's not going to help you with, coupling, cohesion, all that type of stuff. It's not going to help you if you're not using source code control in the correct way, right? So it's kind of the icing on the cake. And the other thing is, it kind of has to add value. So in this case, I wrote all the code. I wrote the test first. I was really happy with what I came up with, and I built it once. And then I was like, okay, yeah, I should go automate all this stuff. But then I was like, you know what? I built it and it worked, and I don't really have a cause to rebuild it at the moment. So I didn't implement any of this. Now, I am thinking about taking this toolkit that I came up with this process for and putting it on the LabVIEW Tools Network. In that case, if I do, I probably will go through all this because they will make me jump through some hoops, and they'll make me make more builds for them, and they will make me do some iterations, and so then it will add some value. So why can I not see the chat window? Does anybody have any questions about that? So this is just to point out that in GitLab, you can have stuff run on various tags, branches, right? So you can specify when stuff runs. You can also just specify stuff to run based on time. So like every night at midnight, do X, Y, Z. That's also a possibility. And it's just to give you an idea too of some of the things that you can do, right? VI Analyzer, Unit Test Suite, you can build VIPs and XDs and all that stuff. So then you do non-LabVIEW stuff too, like copying stuff up to a server like Nextcloud or emailing links, etc. All right, so here's the big picture layout, and we'll see this slide a few times. Basically, for continuous integration, you typically have at least 3 machines. You've got a centralized server, in this case, GitLab, and I use GitLab.com, so it's running on their server. One of the things I like about GitLab is if you're paranoid, you can download the GitLab source code. It's open source, and you can run it on your own server inside your firewall. So that server right now for me, it's GitLab.com and it's exposed to the web, but I could have it hidden behind a firewall. The GitLab server basically runs a couple things. It runs an issue tracker and some project management stuff. It also runs a Git repository and the CI continuous integration engine. And that's all on one server. And then you typically have a development machine, which has LabVIEW installed. And that's where you write all your source code. You write it on there, you push it to the GitLab server. And then the third machine, which in the case of the demo is going to be the same as the development machine, but generally they're different. It's got this program on it called GitLab Runner, which is what establishes the connection with the CI server. And then that's your test build deploy machine. And so the runner is going to issue a bunch of command line interface CLI commands. And so anything you can access through the CLI, if you can access a command, not bash, but batch command, right? At the Windows command prompt, you can do it using the GitLab runner. And so typically you would have LabVIEW running on there, and you might have other stuff running on there. And you may not even have LabVIEW if the whole purpose of this particular machine is just to deploy stuff, to copy it up to some server, then you may not need LabVIEW at all. And you can have multiples of these as well. You can have multiple build, test, deploy machines. Just like you can also have multiple development machines. And so the build, test, deploy machine, right? What happens is when your development machine pushes it to Git to the server, the CI engine reads a YML file inside the repository. And that YML file basically gives the continuous integration server some commands. It goes out and finds the correct build, test, deploy machine, establishes that communication. The GitLab runner then pulls all your code out of the GitLab repository and then runs whatever commands are in that YML file. And then spits all the results back up to this continuous integration server so you can see all the results when you log into the GitLab webpage. Anybody have questions? You guys can interrupt me at any time with questions. So, all right. So we've got to control LabVIEW from the command line. For this demo, I'm using the LabVIEW CLI tool, which ships with LabVIEW 2018. And I want to say if you go and look for it and install it, you can use it all the way back to 2014. There is an alternative. James McNally, who runs Wiresmith, has an alternative, and it's called GCLI. Let me type that in the chat window. I've been told it's better. It's something that I've been meaning to look into. So hopefully I just answered the question there. So yes, I use the LabVIEW CLI tool right now. I'm kind of rewriting all of my CLI process stuff. And one of the things I've learned from talking to other people, and it makes total sense, is that all your CLI tools that you're going to call via the command line, it's a good idea to also make like a GUI wrapper that you can then run any of those from the GUI on your development machine. And I don't have that right now, so I've been thinking about rewriting it to allow that. And as part of that, I was thinking about switching over to the GCLI tool. I've been told it's much faster. That's the one key benefit. And apparently it also has some other options that the LabVIEW CLI does not have. So your mileage might vary. If we go back, the only part that affects is the part communicating between the runner and LabVIEW. So everything else, it doesn't matter. Obviously in your YAML file, you would change some of the commands because the runner is going to run different commands. Right, so what you would change is edit the YAML file, and then on your build, test, deploy machine, you would have to install the GCLI, and it would use that to then talk to LabVIEW. And as you can see, if you go to the command prompt and you just type in LabVIEW CLI, it comes up, it tells you how to use it and what parameters you can pass. And there are a handful of built-in actions that just work out of the box. You can mass compile, execute a build spec, close LabVIEW. You can run VI Analyzer. You can run unit tests. So that's UTF, the NI unit test framework, which I don't recommend. And then, and also the one reason to use the UTF was because the NI created it and it was ISO 9001 certified or something. And so highly regulated industries had to use the UTF because the JKI VI tester was not. But now there's a new competitor and Insta coverage. It's called Peter Bocor, and apparently they are ISO certified. So there's really no reason to use UTF anymore at all. And my understanding is NI is kind of discontinuing it. So, and then the most important one is run VI. So that lets you run custom actions. So as long as the connector pane matches a certain template, you can go do whatever you need inside there, and it'll let you do anything you can do with LabVIEW. And the machine you're running as development, right? So anything you do in the LabVIEW development environment, you can do with the run VI. And it allows you to pass command line parameters too. So why not just go straight LabVIEW exe, right? You could just type in labview.exe and then the name of your VI and it'll run it. Reason not to do that, well, there's no CLI input or output, and there's no error return doing it that way. So it's nice to be able to pass stuff in. It's nice to be able to get data back out. And LabVIEW exe or LabVIEW CLI does the auto logging, which is useful for kind of tracking down what's going on if something goes wrong. I don't know, but I'm sure the GCLI probably also does some logging to help you track down bugs. I'd be surprised if it didn't. All right, so why choose GitLab? Why not use some other thing? There's Jenkins, there's Bamboo, which is the Atlassian one, and there's probably several others. I don't remember the names off the top of my head. Travis CI, I think, is one, and Circle or something, Team City. Well, first of all, GitLab's free. That's a big motivator. I don't have to pay anything for it. GitLab itself, right, the whole thing, you can get up to like a certain number of users and a certain number of repositories for free, and I haven't come close to hitting that limit yet. And when you hit that, you can pay them a couple bucks a month and you can have more. It's a single integrated server, which I like. One of the issues I had with Jenkins is if I wanted to use Jenkins, I had to set up a separate Jenkins server, and then I had to make sure that that could talk to my Git server or SVN server. And I have Git Plus here because it does Git, but it also does a bunch of other stuff in addition to that. It's got some added features for protected branches and different things that aren't native Git stuff. It's got continuous integration. So you define the YAML file and you set things up and it'll run stuff for you automatically. It also does some issue tracking, some time tracking, Kanban boards, project management stuff. Does user management as well. I like it because it gets through firewalls easily. So one thing I forgot to mention, this build, test, deploy machine can be inside your firewall because it's the one that initiates the connection to the server. So therefore, it will get through your firewall and go out, and it's just all HTTP requests anyway. And again, if you want the GitLab itself, the server instance, you can run that either on AWS, right, with your own custom URL, or you can run it inside your network on your own server, or you can use their GitLab.com servers. And really why I like it is the CI setup is really basic. There's a minimum amount of configuration needed. It's really easy to get up and running with. All right, so now we get to the demo part. I'm not actually going to demo this. I'm going to show you some screenshots and walk you through what I did. And if you want, you can play around with it on your own. Oops, sorry. The chat window keeps disappearing. All right, why won't it show me the chat window? Technical difficulties. All right, why is the chat window not showing up? All right, if anybody says anything in the chat, I, for some reason, cannot pull it up. I'm not sure why. I want to check and see if anybody's done anything in the chat. All right, there it is. Okay. All right, let's see. Azure DevOps is another one. Yes, I've heard people mention that quite a bit, particularly at the GDev conference. Several people mentioned they were using that. Building the app builder APIs in LVlib. If you're building a large application using obvious CLI, I can't see its building progress. So I think what you're going to want to do for that, and one of the advantages I'm seeing from the GCLI tool is that it lets you write out as you're going to the console. So you can write out back to the CLI. So you would probably want to do that inside the GCLI tool and use the app builder API stuff in VILib. Yeah, so Ryan is saying you could use the VI-CLI command with those. And yes, you can use the VI-CLI command to throw those. The problem is if you're using the LabVIEW CLI, you can't write back to the command line screen, to the console. But I think with GCLI, you can update that at any time. Just FYI. All right. All right, so basically the steps in the demo, you download a zip file. Right there's the link again. Create a new GitLab project, and you're going to upload all the code. And then once we've got the code on there, it's in GitLab. We've got our Git repository created, all that. Then we're going to do probably the hardest part, which is install and register the GitLab runner. That's setting up that initial connection. And then creating the YML. The YML is actually pretty straightforward, but in this case, I have one written for you. You're just going to drop it in the repository. And then once you check that in and push the changes, you'll see that it fails. They're really simple failures to fix. You go, you fix them, you push it again, and then you can see that it passes. And that'll show you what it looks like when it fails and when it passes. And then from there, you know, you've got all the building blocks to start doing other things. So you can play around with the LabVIEW CLI and run VI and see what kind of VIs you can run and what kind of stuff you can do. And then the YAML file, it's just a matter of going to GitLab help and seeing all the different options there for setting up things like when different jobs run and whether they're allowed to fail and things like that. And that's all really well documented. The first step is just go and download the zip file and explore. And so the bottom folder on the left is what's inside the zip file, right? We've got instructions, which are open on the top right there. Basically walk you through what I'm about to tell you. There's the GitLab CI YML file, and there's a LabVIEW source directory. And inside the source directory, we got a project, sample VI, as you config, and I did file. And if you open up the project, you'll see it just has a sample VI and the VI analyzer config file. If you run that, you'll see that there's a couple failures. So that's just downloading and looking at exploring what's there. The next step is to go into the LV source folder. You want to do this inside the LV source folder because the whole thing is you put the source in source code control and then you drop the YML file in it. So you're going to open up Git Bash, and you can do this with source tree or tortoise Git or whatever you want. Git init creates a new repository. Git add adds everything in the folder to this new repository. then git commit, right? That commits the changes. So now you've got a new repository that's got one commit in it, and it's got all the code that's there. The next thing to do is to push it up to your server. If you use GitLab, you can do git push --set -upstream and give it the name of where you want to put your repository, and then follow that by the words master, which branch to push, and it should create the project for you and push everything all in one command. It's quite handy. If that doesn't work, you can always go to the GitLab.com interface on the web, and through the web UI, you can create a new project, and it has instructions on how to push code up to it. Questions? Why is my chat window not popping up? Is there a way to get that to like continuously stay there? It's hiding. All right, good, no questions. How can I make that stay on top? All right, I don't know how to get that to work. I'll have to figure that out for the next webinar. All right, so at this point, right, we've created our project in GitLab. So we have our Git repository. We have our dev machine. We've got our code here. We've pushed it. Now we need to install the GitLab runner and set up the connection. So for the demo, we're just going to install it right in the dev machine, but you can install it on any machine that has LabVIEW and has access to the internet. And this is a little bit more involved. The best way to find GitLab help, their search engine is kind of like NI search engine. It sucks. Apparently, I don't know. I just always type it into Google and it takes me right there. So if you Google install GitLab runner on Windows, it will tell you how to do that. And if you read through the directions, basically what you're doing is you create a folder, you download this executable file, drop it in the right folder with the right name, go to PowerShell and run it PowerShell as an administrator. And then you got to go through this process of registering. And once you've registered, you install it and start it. And we'll do the register thing in a minute. So here's the register stuff. So you're going to call up this executable, right? Pass it the command register. It's going to ask you some questions, and it kind of guides you. So you enter the GitLab instance URL. Typically that's GitLab.com. If you're running it on your own server somewhere, either inside your firewall or on AWS or whatever, you give it the correct URL to get to it. Then you need a token, right? And that tells it to connect to a specific project. So you get that from going to the GitLab UI, and you go to the settings. There's a setting for runners, and there's a key there. If you look at the screenshot on the right, there's a big red arrow pointing to it. You copy that key, enter it into the command line, hit enter. Then it'll ask you what description and tags to use. Description doesn't really matter. That's just what shows up in the UI, the web UI. The tags matter because the tags are how the CI server knows which runner to run the job on. So for example, you might have multiple build machines, and one might have LabVIEW 2019, one might have LabVIEW 2018, one might have test stand on it, one might have, something else installed on it. And so you can tag them with the software they have installed, and then it will only run on ones that match the same tags. And then for the runner executor, you just enter shell, and that will cause it to run batch commands. So whatever's in the YML under the script section is going to be interpreted as a batch command, and it'll be ran as the command line in Windows. And that's all you got to do. Once you do that, then if you refresh the page in the web UI, you will see that the list runners activated for this project, and it'll have your runner there. And the nice thing is you only have to set up a runner to connect to the server once. And once it's connected, if you want to move it to another project or use it on another project, then that's easy to do. So when you refresh this page, if there are other runners that maybe aren't aren't used on this project, but that you have access to, you can then add them to this project. So you really only have to go through the installing and registering once. And it's not that hard. It's a couple command line things and you're done. Questions? Let's see if I can get the chat window to show up. Nope, doesn't like it. PowerPoint wants to be on top. Okay, so I don't see any questions. All right, so now we've got everything, right? We've got our dev, except for the YML file, right? So we've got our dev machine, put code in it, we push it up to our GitLab repository. We have a dev machine with the runner installed, right? And it's communicating with the GitLab CI server, but nothing's happening when we check code in because we don't have a YML file, which is how we tell the CI server what tasks to run. And so if you open up the .gitlab-ci.yml file that's in the zip file that you downloaded, it looks like this. So the first thing we do is we tell the CI server how many stages we have and what their names are. In this case, it's just testing. And then we set up some jobs. So I have a VI analyzer job. Tell it what stage it belongs to the testing stage. The tag, LabVIEW 2018. So I need a build server that is tagged with LabVIEW 2018. And then under script, what I'm running is LabVIEW CLI-operation name, run VI analyzer. Right, so I'm using the built-in run VI analyzer. I'm passing it the path of my VI analyzer config file, and I'm passing it a report path. And then just for fun, I set up an artifact to grab the VI analyzer report. Now, one thing you'll want to know is by default, it won't grab artifacts if the script fails, right? So in this case, there's something that you can add there, and I forget. I want to say when always or something is what you add to the artifact section so that it always grabs it, regardless of whether the step fails or not. So you'll notice when the thing fails, it won't grab the VI analyzer report, and then when it passes, it will. So I don't remember the exact command. You can Google how to do that. But that's probably worth doing. All right, so for the demo, what we're going to do is then drop that GitLab CI file into our repository, commit it locally, and then push it to the server. And when we do, you should get an email that says, hey, your pipeline has failed. And it gives you some information here and tells you what project, what branch, what the commit hash was. The comment tells you who rendered it, who pushed it. Pipeline number, so all the pipelines get a number so you can reference them. And it had one failed build. And here's the log, and that shows what was output on the console. And if you click on any of those links and go to look at the project in the GitLab web UI, you'll see, right, this red X. You can click on that and drill down, and you can eventually get to where you can see the console output. And this is what actually ran on your machine, on your build machine. So there are 68 tests that passed and 3 tests failed. And you can get the full report there. Again, if I was smarter, I would have added the little code so that it grabbed the artifact, even though it failed, and then you could open up the artifact in the web UI. As it is, if you have access to the development machine, you can go log in and drill down and find that file and then read it. So it's easier to add it to the server. All right, let's see if we have any questions. An artifact is any produced output. Yes, so what happens is an artifact is anything that's not in your repository that you want to carry over from one to the other. Error 3 just means that it failed. So the way that the CLI, the way that the GitLab runner knows that the CLI commands that it sent failed is they output an error. So anything other than 0, I think, is no error state. So any number it outputs That's what outputs, and that comes from the LabVIEW CLI. So yeah, job failed, exit status 3. If you write your own scripts, you can pass out more meaningful error codes. That's just what the LabVIEW CLI happens to put out if the tests fail. More questions? Then the artifacts are then stored on the server, and any subsequent steps, those artifacts are then available. So when the next step runs, the GitLab runner will not only check out the stuff out of the Git repository, also pull all the artifacts down, so then you can have access to them. Good questions. All right, so then the next step of the demo is to go in and fix the VI Analyzer results, make sure they pass, and then you push it, and then you see you get a nice green check mark. And you can also drill down and how do I hide this? It's getting in my way. One second. All right. So you can also see on the right, there's the job artifacts. You can click on download and it will download them for you, or you can browse them. Any more questions? Yeah, that's why, so Alan, that is why I chose to use GitLab CI as opposed to Jenkins, because it is much easier to use. Are there features that it can't do? I haven't run into any yet. If you aren't fluent in writing Git commands, how difficult is it to learn? There is a book. It's an O'Reilly book. It's version control with Git. I'll type it in here, but it's so yeah, if you get the book is version control with Git is the name of the book. It's O'Reilly Publishing. It's got the bat. So it's got the bat on the front. There's a pocketbook. You want the full-sized one. And if you read that, it will tell you everything you want to know about Git and all the commands. There are a lot, and it gets confusing. There's only a handful that you really need to know to use regularly. What I started using is a product called SourceTree, which is from Atlassian, and it's much nicer. It's got a nice GUI interface and everything. I mean, we're doing LabVIEW programming. Can you survive GitLab without Git at all? I'm not quite sure what you mean by that. Can you learn how to use GitLab without knowing how to use Git? So you kind of have to understand the basics of how Git works. But once you get that, you can use SourceTree and probably be okay. I still think it's worth learning the commands because then you know what all the options are, and there's some like little tricky gotchas here and there. I mean, especially like if you get into stuff like trying to use submodules and stuff, there's some things that you got to understand. And it's possible to back yourself into a corner. Can you use GitLab just for the CI? That I don't know. I have not tried. I want to say I think there is a way to do that, but I don't know how. I don't know. So that is one nice thing about Jenkins is that it will let you do stuff with Subversion, with basically it can use any source code control thing you want. So it doesn't really care as much. So yeah, hopefully that answers your question. That's not the best I can do. Other questions? The output files you send to the customer, whatever you want. So basically, the CI is an internal thing. And then as far as sending to customers, you could send them the report from the unit testing if you wanted. So you would basically use SMTP to send an email. So you could do that through LabVIEW, you could do it through Python or some other means, and just send an email. If you have the server, email it. Or you could have it save the artifact, and if you give your clients access to your GitLab repo, depending on what access rates you give them, they can have access to that as well. So hopefully that answers the question. All right, so the next part of our discussion of this is just a little bit of virtual machine discussion. Then there's one other little thing to discuss, and then we'll move on to just questions and wrapping things up. So the virtual machine part of it, I don't know if any of you guys use virtual machines. They're quite useful. Why you would want to use them? Well, if you've installed multiple LabVIEW versions on the same machine, you'll know that can be a pain. Oftentimes I work on different projects of different driver requirements, and sometimes they're incompatible. Some projects require third-party software to be installed. Sometimes you might want to test stuff on different OSs, right, for your testing. Different things like that. So what I typically do is I create a virtual machine. When I start a new project, I have a LabVIEW 2019 base virtual machine. I start my project on that. When I find out I have different requirements as far as drivers, I'll clone that, create a new one. I'll have one virtual machine just for that particular project. And since my build server uses VMware and I use VMware, I just then copy that onto my build server. And now I have a copy on my build server that can do all my building. And I've already only installed the drivers once because I install it on my dev machine and then copy it. And that seems to work pretty well. Part of this discussion was about, at NI Week, was about trying to figure out how to launch VMs dynamically so that they're not constantly running and taking up space on my server. And I have not figured that out. So if anybody has any interest in that, we can perhaps continue that conversation offline. So Chris says he loves VMs, and for what's worth, NI tech support can refuse to assist you. If you hit into problems with using a VM, I would believe that. Chris would know. Chris used to work for NI. So, yeah, so Mark's question was, do you keep the VMs running all the time? And that is the big rub. So the development ones, obviously, you just fire up when you're using them. The ones on the build server, that is a tricky question. There is apparently a way with GitLab CI and VirtualBox to do it automatically. So automatically launch a new instance of your VM when you run a job that requires it. If that's something that's really important to you, I suggest check that out. I tried to reinvent the wheel with VMware and I did not get very far. I'm sure it's possible. It's just more work and effort than I put in at the moment. For me, it's just me. So I'm pretty much never working on multiple projects at the same time that I can't, go home and just fire up my build server. But that would also be a good thing to make all your CI stuff executable locally. So if your build server, for whatever reason, is down and you've got to make a build, you can use the same tools that you'd use otherwise. Are artifacts also pushed to repository? No. They are just pushed to the CI server. So it'll show up when you browse through GitLab and go through the different CI jobs, but they do not end up in the repository. How many cores do I dedicate to a build server? I don't know. I have a quad-core Xeon or something that runs my build server, and yeah, I was just reading Chris's comment. Sorry, I got distracted. So yeah, cores. It just depends on what you're doing. I don't know if there's a right answer to that question. I did not know that about Hyper-V, Chris. Dynamic RAM. I will have to look into that. Yeah, right now I don't really have issues. Because like I said, I only have 1 or 2 projects going at any time, and when the project's over, I just stop the build server and let it sit. And if I know I'm not going to be using it for a while, I can stop it. And yeah. All right, let's see. Let's just skip that. So the next discussion then was more on reuse, right? How do you write these things so that they're reusable? Right now, I use Git submodules. So I have a CLI tools repository, and all my other repositories reference that as a Git submodule. I find it very useful. I put any CI scripts I have and custom VIs in there. Another thing that helps making things reusable is GitLab CI variables. It allows you to write one script and then run it in multiple projects because you can define different variables. So there's some built-in ones, and you can define custom ones. So that works very well. And then managing dependencies. So aside from having different repositories for every project, due to different dependencies, all your dependencies are VI packages. You can do these package configurations. And it does require the Pro version, but you can create a VI package configuration that says these are the packages I want to install. And they're all there in the file. And then before you run any jobs, you just apply that. And it seems to work quite well. All right, sorry, just checking the comments really quick to make in the chat box, make sure I didn't miss anything. And so that is pretty much the presentation. If you want to learn more, you can use this QR code or the link there and set up a free 1-hour call. We can just talk about how all this applies to whatever specific problems you're facing. And you know, if you're interested, we can talk about how we can work together in the future on projects. So yeah, if you want to do that, use the link. Anybody have any questions? That worked out well. That was about an hour, so that's perfect. Thank you. I hope you all found it useful. It will be recorded, so it should have, when you signed on, it should have said it's being recorded. So I will send out a link to everybody who's on the list with a video. If you really want the PowerPoint, I can probably get that to you too. Just send me an email and I'll send you the PowerPoint, but the recording is probably what you want. Can I help with virtual machine creation? Yes. Depends on what you're using. Sure. Yeah, send me an email and we can talk about that. The virtual machine thing, it really depends on what you're using. I'm not super knowledgeable about Hyper-V or some of the other technologies. I do know a fair amount about VMware and VirtualBox. They all kind of work the same. So. All right. Thank you guys for coming out. I appreciate it. I'm thinking the next webinar will be the test-driven development presentation that I presented at GDevCon. So just in case anybody's interested, that's kind of what I'm leaning towards. I'll make an announcement soon once I figure all that out. Thank you. I'm glad you found it interesting. Hopefully, you'll find it useful and be able to apply it. If you signed up for the webinar, I already have your email address, so you will definitely get an email with the link. Okay, well, thank you guys for coming out, and I got to get going. Chris, we can continue this conversation some other time if you want. So, yeah, I definitely, I think it's by far easier and simpler to set up than Jenkins. Oh, I should also mention, if you look up, and Chris might know this, I want to say decaf has some pre-built functions. So if you look up decaf, they have a section on all their CI stuff, and it's all public. They do use Jenkins. I haven't actually looked at what they have, so I don't know. Oh, I sent that to Chris. I should send that to everybody. Some previous stuff. So if you look up decaf, oh, okay, so they're moving to Azure DevOps. Yeah, actually, I had heard something about them moving, but so yeah, decaf, and I want to say they use the same ones also for Veristand, and both of those are available if you Google it. You can find their GitHub, or I think they're on GitHub repo, and yeah. So, all right. Well, I'm going to keep going and close down the meeting, but thank you all. And yeah, if you want to get in touch, you can find me on LinkedIn or Twitter or something, and you can use this link to get a free 1-hour phone call. So thanks. Bye.